Well, we know writers do this all the time, right? The gotcha, the shock value, all that stuff. But someone wrote this because they looked at this number. So they said, fewer Americans favor the death penalty. We're smarter than this. You know what, everyone? Maybe the proportion they got, the sample, maybe it was lower than. Okay, it's less than. What we know about in statistics, we want to know whether the results are already statistically significant. All right? To make that kind of statement, we got to see that the results are statistically significant. That's what we're going to test. All right. So less than, and here I'm going to do a what? Less than. We're going to see if these results are statistically significant or not. That's a powerful statement just to say off the sample they took. So when here comes the sample. Sample size was 1,025. 653 said yes. 653 out of 1,025. This denominator always has to be the biggest number, right? So me, if they write this out of order, we always know the bigger number's there, right? Yes. This many said yes out of this. So what is that?
0.637.
637, is that good enough?
Mm-hmm.
Yeah.
Well, it's lower than this. Do y'all agree?
Mm-hmm.
We get that. Someone wrote an article because of that. Right? Oh, it's fewer Americans now. It's like, yeah, but that was just one what? Yeah, someone took one poll. That's a strong statement. We're saying statistics. Hold up. Is these results right here statistically significant to make that kind of statement? To say you really have evidence suggesting that it's what? Lower than this, right?
Mm-hmm.
Cool. Welcome to statistics. This is what we're talking about. We challenge people. We go write an article. We can write a letter to the editor. We can write a letter to that. We see what we get out of this. All right. Well, let's see what's going on. Are the results statistically significant? Of course, we can see that's lower than that. But that's a powerful statement someone's writing in this article to say now it's lower. You took one poll, so now we're going to go with this. And let's.
One second. What is the level of significance? They didn't give that.
Oh, you're the best. Everyone, before I do this, I have to give that level of significance for this problem. And this problem, everyone, it was 5%. It was 5%. All right. Is everyone okay if we just bypass the checks? Yep, okay. Let me check out. Oh, and you know why? Look at that sample size. That's huge, right? You know it's going to check out. We're good there. Hey, next class, I will discuss the small sample size. Because there is a way to do this. You're like, what if we got a sample size and this number right here came out to be like a 4? There's still ways to work with the problem statistically. But you bypass the classical approach, you just get a p-value. But do you remember the binomial distribution?
Mm-hmm.
That's all we do. We pull out the binom CDF button. That's all we do. So I'll talk about that next class, if anybody's interested in that. To me, I'm like, it's not a big deal, because if you did your own study, you would just get a sample size big enough, right? Yeah. All right, class approach. I'll make a bell. Is it Z or is it T?
Z.
I love it. And when you'll crush this during the test, this is the one part I need you to be careful of. I'm getting out the yellow chalk. This is what the calculator doesn't do for me. That number, which I forgot to write down, thanks Art, came out of the word problem, 5% level significance. Where do I shade? And because it's a one-tailed test, right? And this indicates where I shade. You know, we're testing whether or not, you know, has the proportion really dropped from 65%? We get it, one little sample here. This is inferential stats. So I'm going to shade 5% on this side. I'm still holding my yellow chalk. I need my Z crit. I need a Z crit. All right, what's my Z crit? In this case, T, I only get one value. Is it going to be positive or negative? Negative. So I might as well get my negative symbol ready. She knows it's going to be a negative Z score. Look, it's on the left side. Now, this depends. Do you like this thing? Okay, what percent is it? Don't cut it in two. One tail tip, 5%. Go look up 5% on this sheet. You'll get it. Right? y'all get?
Negative 1.65.
Is that the same number as before? Okay, Aaron. Isn't that the same number as before? You'll when I have two z-scores memorized. The one where it's 5% here, 5% there, and 90% in the middle, or when it's 2.5% there and 2.5% there. So when I'm getting a z-crit of negative 1.645, you'll probably memorize them as well. Not because you wanted to memorize them, you'll just see the numbers so often. The two most common z-scores for z-critical values are negative 1.645 here, and the negative 1.96, which is really close to a negative 2. That's for the, 2.5% each, on the tail. All right, you got that? Anyone remember what we're doing now? The fun stuff. Let's do it. And we'll just go bop, we'll go bop, we'll go bop, and on Thursday we'll just continue with this. We can practice confidence intervals and means. Unless you're like, I got this stuff down, I don't have to go to his review. Should we put it on video? What do you think? Still the review? What do you all think? Oh, okay, we'll do that. I know you're like, nah, don't put it. Yeah, we'll definitely do it. All right, so I'm going to go to stat. Which button do I want? T-test or one prop z-test? Oh, wrong menu. I love it. One prop z-test, right? It's a hypothesis test for proportion. Me after this, let me know if you want to do the Keno stuff. Of course. I brought it up. All right, what's the null? 0.65. What was X? 653. 1,025. Which one of these do I want?
Left.
Now, how do I make it stick there?
Enter.
Your call, calculator, draw. I like calculator. Stare at the p-value, and you know your answer. Stare at it. Just stick right there. I wish the calculator said p-value. It just says p, but that's the p-value. And when the p-value is low, reject the hoe. Is that lower than 5%?
No, greater. So the
We
status
know all the answers. Heck, I can write out of order. What's this?
0.19.
That's good enough, right? Is there evidence? What do y'all think?
No.
There is not evidence. Suggesting. There is not sufficient evidence. You want to use the word sufficient. There is not sufficient evidence. Suggesting rho is greater than 0.65. Notice that when I always reference the what? The alternative hypothesis, my conclusion. Look, I can go out of order. What's my interpretation? This is the probability of obtaining the results we got up here, or more extreme because we shaded to the left, given that, what was the null? Don't you notice how I wrote the null here? Everything was based on given that this was what? The real deal. Given that this is truly, really 65%. But because my p-value is it higher or lower than the alpha level?
Higher.
It's higher. Because my p-value is higher than this level of significance, because a 0.19 is greater than a tiny, unusual 5% probability, we do not reject the no. I'm writing out of order, aren't I? It's no problem.
So for the null hypothesis, but the one underneath, I forget what it is.
Oh, the alternative.
Yeah, so it's P is supposed to be less than 0.65, but it says suggesting that P is greater than 0.65.
Oh, right here.
Down
This one
below,
right here?
on there's not evidence suggesting that P is.
Oh, okay. So right here, when I wrote this.
No, not that one, the one in the conclusion.
Oh, you're the best. Right here. You're the best here. She's pointing my
That's
ear.
why I was confused, because when I.
Pierre, you're the best. You're like, listen, when I say there's not evidence, I'll erase this. And I appreciate you noting that, Sarah. When I put my statement here, you're right. I always write exactly what I see right here. I will repeat it, because this is what we went on to check, this alternative hypothesis. So thank you so much, and I'll put that. There is not evidence suggesting that. I'll just put my alternative hypothesis, which is the population proportion is actually lower than 65%. Sierra, thanks so much. Hey, didn't the article start with this? And look what we're saying. We've got statistical evidence suggesting not. Even though this was lower than, yeah, that was one sample, right? The results, it's lower, but it wasn't statistically significant. Hey, what's this number? Negative what?
8.67.
Where is that in this picture?
That's.
Because this is negative 1.6. Here's z equal to 0 right here. Where's like a negative? It's close to a negative 1. Yeah, it's probably about right here. And when that's negative 1, right there is my z naught, which was equal to this negative 0.867. Sierra, thank you again for spotting it. I wrote that symbol the wrong way. Oh my gosh. Now, is all this making sense, Sierra? Is everything good to go?
Yeah, I'm just checking the calculator thing again.
Awesome. Check it out. And everyone, watch how everything flows. This is not an error. There is not evidence, right? We do not reject null, right? And what if this number wasn't here? This number would have been lower than the 5%. This would be lower than this. We would reject the null. There is evidence. Isn't this cool? Look, we got everything, true? And we'll look it over. Do we have everything? So on Thursday, do you all see how fast that goes? Let's do some with means. Let's do a two-tailed test. Let's go back to confidence intervals. So you aced the what? Hey, there's one other thing I'm going to make sure to do. Holly, would you remind me of this one? On Thursday in review, when we did confidence intervals, remember there was a problem about determine the sample size necessary? I want to do one of those.
You mean the N?
Yeah! And with super job, inferential stats. I will cut that off. You still